Here you see, this is the circle. This, suppose this is A, B, and this is C. So ACB is a portion of this circle. This angle is 90 degree. So magnetic field, so for magnetic field for this ACB portion or BCA portion, so magnetic field for BCA portion can be calculated by this equation. So it will be mu 0 by 4 pi into, this angle is 90 degree, so it can be written as 90 degree can be written as pi by 2. So this, it will be pi by 2 into I divided by R. This divided by R. So direction of the magnetic field, the current is along this direction. So magnetic field is outward. Okay. So in this case, this is only k cap, that means outward, positive z axis. So it will be mu 0 by 4 pi into pi I by 2R k cap. So it will be pi cancel out, so mu 0 I by 8R, and the direction of the magnetic field along the direction of z axis, so it is mu 0 by 8R. Okay. Now magnetic field for the AB portion at O point. What will be the magnetic field at O point? So you have to calculate the distance from this AB straight line. This is 90 degree, so it must be 45 degree. It must be 45 degree. So what will be the distance from this current carrying wire? So this distance can be calculated by using the equation sin 45 degree. Suppose this is R. Okay, this is R. So if I use sin 45 degree, it can be written as, this is D by R. Okay, this is the triangle BO. Suppose this is D, so BOD, this is 45 degree angle. If I write sin 45 degree, then it can be written as D by R, or you can not, this is distance, so you can using the cos 45 degree, it can be written as cos 45 degree. Okay, so cos is given by this divided by this, so it is 1 by root 2 equals to D by R. So in this case, D equals to R by root 2. Okay, in this case, D equals to R by 2. So this is 45 degree. That's why using this triangle OBD, cos 45 degree is given by D divided by this. Okay. Now what will be the magnetic field for this portion AB? AB is given by this equation. So this is mu 0 by 4 pi, this is I, and this D is R by root 2 into sin 45 degree, sin 45 degree. So sin 45 degree plus sin 45 degree. So it will be mu 0 by 4 pi into root 2 I by R. This is 1 by root 2 plus 1 by root 2. The direction will be, this is the direction of current, so it is inward. So the direction will be minus k cap, that means inward. Okay, so it will be mu 0 by 4 pi root 2I by R. This will be 2 by root 2. Okay, so this root 2 cancel out, and 2 is cancel out, so it will be mu 0 I divided by 2 pi R, and the direction of magnetic field is along the minus z axis. So this is opposite direction and this value is greater, so magnetic field for this portion at O point is greater than this portion. Okay, so total magnetic field at O can be calculated as greater minus less value. So this is magnetic field, total magnetic field at O, that O, okay, this portion, okay, for this problem. So magnetic field due to this, and magnetic field for this AB, magnetic field for this AB portion is greater than this portion. Okay, so magnetic field, resultant magnetic field is given by mu 0 I by 2 pi R minus mu 0 I divided 8 R, and this is the direction of magnetic field minus k cap, that means inward, minus k cap, that means inward. So it will be, if you taken mu 0 I by 2R common, then it will be 1 by pi minus 1 by 4, and this will be minus k cap. This will be minus k cap. This is the total magnetic field at O point due to this arrangement. Now the problem number 5. This is the problem number 5. This is a infinite wire, this is the infinite wire, this is a circle, and this circle has a radius, suppose R, this is the radius R, this also R. Okay, you have to calculate magnetic field at O point. This circle is in YZ plane, so if I take, this is x axis and this is y axis and this is z axis, so this circle is YZ plane, that means this circle is along this direction and this straight two wire is along this x direction. Okay, so if I take, this is A, this is B, this is C, this is D, this is E. So magnetic field for the AB portion, magnetic field for AB portion is given by this equation, mu 0 by 4 pi I by D, D means R. Here is sin theta 1 and sin theta 2. One is 0 and another is also 90 degree. So it is sin 90 degree plus sin 0 degree. Okay, so it will be mu 0 I by 4 pi R. Direction of the magnetic field, this is, so this is ID, so this will be Z axis, this will be along the direction of Z cap, so it is K cap, along the direction of K cap. This is AB, so this is AB, so if I take I, this is current and this is D, so this portion and this portion. So this is y cap, not z cap. Okay, this is z axis, this is y axis, and this is x axis. So current through this portion is along this direction. This is my thumb rule. So if I take this thumb is along this direction, moving along this direction, this is r direction, so it will be y cap. Okay, that means direction along the y. So this direction is not k cap, it is j cap. Okay, and magnetic field for this portion DE, this portion at O, is given by mu 0 by 4 pi. It will be similar, so I by R. So in this case, direction is also y cap. That means RS, this direction is y, along the direction of y, so it will also z cap. Okay, so this is the, suppose this is x axis, this is y axis, this is the DE portion. So DE, the direction of current, if I move my along the direction of R, so it is y cap. Okay, that's why this is j cap. Now you have to calculate this magnetic field for this portion BCD. So magnetic field for BCD portion. This is half circle, so this is mu 0 by 4 pi, this is pi by pi I divided by R. Okay, the direction is along x cap in this way. This is x cap, that means I cap. So it will be pi pi cancel out, so mu 0 I by 4 R I cap. So total magnetic field is given by, these two are same direction, so it will be plus, so it is mu 0 I by 4 pi R plus mu 0 I by 4 pi R, this is j cap, plus mu 0 I by 4 I cap. Okay, this is the total magnetic field at O point. So if this will be 2, so it will be mu 0 I by 2 pi R j cap plus mu 0 I by 4 I cap. So if I take common, so B total is given by, this is the for 5, so B total is, you can take common mu 0 I by R, 2R, so mu 0 I by 2R you can take common, so mu 0 I by 2R, so it will be 2 half I cap, and this portion it will be pi, only 1 by pi j cap. So this is the total magnetic field at O point. Okay, this is the magnetic field. Now this is the problem, another problem. What is the problem number 6? This problem, this is the infinite wire, this is also infinite wire. These two wire, the angle between these two wire is 120 and this angle is only 60. So you have to calculate magnetic field at this point. So if you draw this in this way, parallel to this, this portion is parallel to this, and this portion is parallel to this. So if I draw a perpendicular, this is perpendicular distance, this is also a perpendicular distance. Okay, so this angle is 90 degree, this angle also 90 degree, because I have drawn perpendicular distance from this point to this two wire. Now this angle is 60 degree, so it must be 60 degree because total is 120 degree. Now what will be this angle? This is this two angle. If this is 60, this is 90, so it must be 30 degree. It must be 30 degree, because if you look this triangle, this is the, suppose this is P portion, so PO, this is suppose D, this is suppose E, so POE. So this is the triangle, this angle is 60 degree, this angle is 90 degree, because I have drawn the perpendicular distance between O and this straight wire. So this angle is 30 degree, this angle is 90 degree, and this angle is 90 degree. Okay, so magnetic field due to this portion and magnetic field at this portion can be calculated by using this formula. Okay, so this is 66, number 6. Suppose I have take, this is P, this is Q, this is R. So QP portion, so magnetic field for QP portion is given by mu 0 by 4 pi into I, and you have to calculate this distance. Okay, you have to calculate this distance is D, so this is 120. So using tan theta you can easily calculate this distance. This is, if I take tan 60 degree, tan 60 degree, this is 60 degree. Okay, so tan 60 degree can be written as OD perpendicular to this, so not tan, it can be written as sin theta, sin 60 degree. So if you take sin 60 degree from this triangle OPD, then sin 60 degree can be written as OD divided by D. Okay, divided by D. So it is root 3 by 2 into OD equals to OD by D. So it will OD equals to root 3 D by 2. So it is root 3 by 2. This is D, and this is sine, one is 30 degree and another is 90 degree. So this is 30 degree and this is 90 degree. Okay, so it will be mu 0 by 4 pi, this is 2I root 3 D, this is half plus this is 1. So it will be mu 0 by 4 pi, and this is 2I by root 3 D, and this will be 3 by 2. So these two cancel out, and from this point it can be written as root 3. So root 3 mu 0 I divided by 4 pi D. The direction of the magnetic field for this portion is along the direction of negative z axis. So this is k cap minus k cap, that means inward. Okay, and magnetic field for the portion PR will be the same value will be same, root 3 mu 0 I by 4 pi D, because all the angle are same and distance are same, and the direction is along the direction of minus k cap, that means minus negative z axis. This is inward. So if you add this two value, then you will be getting the total magnetic field at O point for this structure. So total magnetic field can be written as this is both are same direction, so total magnetic field is equal to 2 multiplied by root 3 mu 0 I by 4 pi d. This is inward. Okay, so this is 2, so it will be root 3 mu 0 I divided by 2 pi d. This is inward. Okay, so this is the